Hi, so this is another prerequisite video. I will be talking about three things, and these are really important. First, units of angles, degrees and radians, and I will be talking about how to convert something given in radians to degrees and how to convert degrees to radians. The second is I will talk about a few properties of triangles, and actually I'll talk about one property of triangle, and after that I will be only talking about right angle triangle, and at the very last I will be talking about trig functions. Now these things are really important to build a very solid foundation for this course. So every time you feel like you're not comfortable with this is something you can always come back and look at, but I would really recommend to nail these things down, because if you don't do it, it will always come back and haunt you. So first of all, degrees to radians and radians to degrees. Now if I ask you what is the angle between this edge and this edge, you will just tell me it's probably 90 degrees, right? So we have got an understanding of what degrees are. This is 90 degrees, this is more like 45 degrees, this is like 30 degrees, right? But radians is something that we have no understanding of, because we don't use it. And I don't have much understanding of radians, but I can surely convert degrees to radians and radians to degrees, and that is exactly what we will be starting with. So radians to degrees. Let me start with degrees to radians, because that is what we have. That is what I have in my notes. Degrees to radians. So if you have a number that is in radians, you need to convert that into degrees. The degree value will be equal to radian times, again I made a mistake here, degrees to radian, right? So the radian value will be equal to degrees times pi divided 180, where pi can be used as to be equal to 3.14. Example, let's say I need to convert 45 degrees into radians. So the radian value is 45 in place of degrees times 3.14, because that is what the value of pi is, divided by 180, and you will see that this will turn out to be 0.785. So 45 degrees is equal to 0.785 radians. See, if you had told me, okay, tell me what 0.785 radians is, I would not be able to. But if you tell me, okay, show me what's 45 degrees, I would say it would be like something like this. Now radians to degrees. I really butchered that spelling, but you know what the spelling of degrees is, so I don't have to worry about too much. So radians of degrees, the radian value is equal to degree, radian value is equal to degree times 180 divided by pi. So again I made this mistake, I need to convert radians to degree, right? So should have degree here, radians here. So you put the radian value in place of radian. So example, I have, let's say again, let's check this out, 0.785 radians, right? So this should be about 45 degrees. So according to the formula, the degree value is equal to 0.785, that is the radian value, times 180 divided by pi. 0.785 times 180 divided by 3.14, and you can look up, and I have done this calculation, you should get that this will be equal to 45 degrees. So 0.785 radians is equal to 45 degrees. On to the second topic, triangles. Now triangle is a side that looks like this, not like that, but like this. this. Okay, this is a triangle. It has three sides, and the angles, let's say alpha, beta, and gamma, they follow this rule: alpha plus beta plus gamma is equal to 180 degrees. Now you will be using this property a lot. What you will be doing is, you will probably know two angles out of the three angles, and you will need to figure out the third one. So what you do is, you write down this equation where the sum of all the interior angles is equal to 180 degrees, and that is how you figure out the unknown angle. Now this was just one property that I wanted to talk about, triangle, and the other properties and trig functions are all about right angle triangles. So everything after this is about right angle triangle. So a right angle triangle is a triangle which has one angle to be 90 degree. Right angled triangle. Okay, so it will be, let's say, okay, and that angle, let's say, is this. This is the angle, that is 90 degree. When you have a 90 degree, you make that little square as an angle, as a symbol to that angle. Okay, let's say this side is A, the length of that side is A, length of BC is small b, and length of AC is C. Now C is the length of the hypotenuse. Hypotenuse is the longest side. It's the shortcut distance. That's what hypotenuse is. Hypotenuse. Right. Now Pythagorean theorem is attributed to this scientist who back in the day called Pythagoras, and he said that when you have a right angle triangle, this is true. C square is equals to A square plus B square, or hypotenuse x squared is equal to the sum of square of the two other sides. So let's say if I have A equals to 4, B equals to 3, I can calculate what C will be equal to. That is C square is equals to 4 squared plus 3 squared, 16 plus 9 equals to 25, and this gives C equals to 5. So that is an example of how to use Pythagorean theorem. Remember, only valid to right angle triangles. Now let's talk about trig functions. Trig functions. This is also about, that's right, right angle triangle. Okay, let's say this angle is alpha. Now opposite to alpha is AB, right? So that side is called opposite. Adjacent to alpha is BC, so that side is called adjacent. And the shortcut distance, or the longest side, that is AC, is called hypotenuse. Just when you use trig functions, if you're having difficulty solving a problem related to trig functions, just think of this example. Make a triangle like this, and then just name those sides, right? And remember these ratios that I will be talking about in a minute. Now, so these are trigonometric functions, right? So they are functions of the angle. So you say, so let's say one of the functions that is important is sine, and you write it as sin, but you call it sine. You do sine, and then you say sine of something, that is the angle, right? Alpha is equal to, sine is equal to opposite over hypotenuse, right? So opposite is AB, hypotenuse is AC, and that is equal to A over C, right? A over C. Cosine alpha is equal to adjacent over hypotenuse. So cosine is adjacent over hypotenuse. Adjacent is B, hypotenuse is C. Tangent of alpha is equal to opposite divided by adjacent. So it means it's equal to A over B. Now remember, these are very angle centric. That means this is only valid, these ratios will be the same, like the definition is opposite over hypotenuse or adjacent over hypotenuse or opposite over adjacent. These definitions are always the same. It's just that the meaning of those, or you can have different sides being called differently depending upon what angle you're talking about. So for example, here let's say if this is angle and this is some angle called beta, then sine of beta will be opposite over hypotenuse, but for beta opposite is this and hypotenuse is this, so it's going to be B over C, which was A over C for alpha, right? So let's see what tangent will be. So tangent of beta is opposite over adjacent, right? So for beta, opposite is this and adjacent is this, so it's going to be B over A. So it really depends on the angle in a triangle, what will be the ratio. Okay, the definition of these trig functions remain the same. It's just that opposite can be adjacent to a different angle and vice versa. So let's do an example of this. Suppose you have a triangle, right angle triangle, and this side is 4, this is 3, and this we don't know. Okay, and this angle is theta, and I need to calculate this side. So this is side, let's call this hypotenuse as C. Okay, so I can use this definition. Tangent of theta is opposite over adjacent, so opposite to that angle theta is this, adjacent is this, so that ratio is equal to 4 over 3, and that gives out to be 1.33. That means tangent of theta is 1.33. Now theta after this can be written as tangent inverse 1.33, and if you have set your calculators to be degrees, this will give you an answer that will be equal to 53.06 degrees. Now I'm not able to recall, but I might have said that we're going to find the length C. I was incorrect. We were going to find the length, not the length, but the angle theta from the trig function tangent. So you see, this is an example where you knew the two sides 4 and 3, but you didn't know the angle. You were able to find that angle using the definition of tangent, which is equal to opposite over adjacent. You take the ratio 4 over 3, then you use tan inverse to figure out that angle.